There are three special angles that we want to be familiar with, and we want to be familiar with all of their trig function values. And those special angles will be 30 degrees, 45 degrees, and 60 degrees. We will have to memorize all of the trig function values of these three angles. Now, instead of just rotely memorizing them, we can actually develop what we call our special triangles to help us develop all trig function values for these three special angles. In order to do that, we're going to start with an equilateral triangle. In this equilateral triangle, we'll have all of the same angles of 60 degrees and all of the same sides of 2. And what we're going to do is we're going to take this equilateral triangle, I'm going to cut it right down the middle, we're going to cut it in half. Now when I cut it in half, what happens is that we get, and let's look over here, we get 30 degree, two triangles where 30 degrees at the top, so we split that in half, so that's 30 degrees each. And down here we still have 60 degrees, and then here, because we cut it straight down, we have a 90-degree angle for both of these triangles. Now we're just going to pay attention to one of them, so I'm going to redraw one of them right over here. This is what we call our 30, 60, 90 triangle. And the hypotenuse for this will be a length of 2. That's the longest side of our 30, 60, 90 triangle. And if I look down here by the 60 and 90 degrees, we have a length of 1. Now we want to know what is the length of that third side. So we can use the Pythagorean theorem to develop or to find the length of that third side. So we already know the hypotenuse, so we're looking for 1 squared plus, let's call that x, since we don't know it, x squared is equal to the hypotenuse squared. So that would be 1 plus x squared is equal to 4. And subtracting 1 from both sides, we get x squared is equal to 3. And then take the square root of both sides. So the length of that side that we didn't know will be the square root of 3. And this is what we would call our 30, 60, 90 triangle. If you know this special triangle, then you can find the trig function values for 30 degrees and all of the trig function values for 60 degrees. Now when you're looking at this triangle, remember the hypotenuse, the length of the hypotenuse is always the longest. So when I look at these three lengths of these sides, the 2 would be the hypotenuse. It's the longest of the three sides. Square root of 3 is about 1.7. You could put that in your calculator to find an approximation. But square root of 3 is the second largest, and it's across from the second largest angle in our triangle. And 1 would be the smallest value, and 1 is the side that is across from the smallest angle. So we want to have this memorized so that we can use it to find all of the trig function values for 30 degrees and all of the trig function values for 60 degrees. Alright, so now let's use those special triangles, that special triangle that we formed, our 30, 60, 90, to find all of the trig function values for 30 degrees. So here's my special triangle that we just developed. We're going to take the perspective of the 30-degree angle, and we're going to look for the side that is opposite. We're going to look for the side that is adjacent, touching the angle, and of course the side that is across from our 90-degree angle will be our hypotenuse. So when we go to find the angle for 30 degrees, we want sine of 30 degrees, that will be the opposite side, so that would be 1 divided by our hypotenuse, which is 2. So sine of 30 degrees would be 1/2. Cosine of 30 degrees will be the adjacent side, square root of 3, divided by our hypotenuse, which is 2. So the cosine of 30 degrees is the square root of 3 divided by 2. And tangent, that is the opposite side over the adjacent side, which is square root of 3, so 1 divided by the square root of 3. And of course, we are going to find the rationalized version of this. So the tangent of 30 degrees will be square root of 3 divided by 3. Now we will find the reciprocal function values. If sine of 30 degrees is 1/2, then cosecant of 30 degrees will be 2. Remember, these are reciprocals. Secant of 30 degrees will be the reciprocal of cosine of 30 degrees, so we will do 2 divided by the square root of 3, and we will rationalize. So we get 2 square root of 3 all over 3. Put these in little boxes here. And finally, cotangent of 30 degrees will be the reciprocal of 1 divided by the square root of 3, and that will just be the square root of 3. So we don't have to necessarily have these memorized. If we know our special triangle, then we can work from the perspective of a 30-degree angle and develop all 6 trig function values. Now let's do the same thing for 60 degrees. So we're going to take that same 30, 60, 90 special triangle, and we're going to work from the perspective this time of 60 degrees. So the side that is opposite of our 60-degree angle will be square root of 3. The side that is adjacent will now be the 1. That's the side touching our angle, and our hypotenuse is still the side across from our 90-degree angle, that's still 2. So sine of 60 degrees will be opposite square root of 3 divided by the hypotenuse, which is 2. Cosine of 60 will be the adjacent side, which is 1 divided by the hypotenuse, which is 2. So cosine of 60 degrees will be 1/2. Tangent of 60 degrees, we will do opposite square root of 3 divided by the adjacent, which would be 1. So we really just get square root of 3. And now we will work with the reciprocal function values. So cosecant of 60 degrees will be 2 divided by the square root of 3. And we will rationalize. So we get 2 square root of 3 divided by 3. Secant of 60 degrees will be 2, reciprocal of cosine, and cotangent of 60 degrees will be 1 divided by the square root of 3, and once again we want to rationalize, so we get square root of 3 divided by 3. Now if we compare these, once again we can see that since we're working with the same right triangle, that the cofunctions of these angles are the same. So if I look at sine of 30 degrees, sine of 30 degrees will be the same as the cosine of 60 degrees. These are what we call cofunctions. If we're working within the same right triangle and we're working from the perspective of two separate angles, their cofunction values will be the same. Let's look at another one. Tangent of 30 degrees should then be the same as cotangent of 60 degrees, and we see that they are the same. This is why we call them cofunctions, because they're angles that add up to be 90 degrees within the same right triangle, and their cofunction values will be the same. To find the trig function values of 45 degrees, another one of our special angles, to find this we need to develop another special triangle, and we're going to use an isosceles triangle, and an isosceles triangle means that we have a 90-degree angle here, we have two of our sides that are exactly the same. So I have exactly the same angles, and the lengths across from them are also exactly the same. So we need to figure out what is the length of that third side, and that will be, well, we have 1 squared plus 1 squared, and we are looking for the hypotenuse here, so we'll call that x squared. That will be 1 plus 1, which is x squared, 2 equals x squared, and then take the square root of both sides. We get that this side will actually be a length of the square root of 2. So, it doesn't matter which 45-degree angle we use, we will use one of them, and we will work from the perspective of this 45-degree angle. So, the side across from it will be the opposite. The side next to that angle, touching it, will be the adjacent side, and the side across from our 90-degree angle will be our hypotenuse. So the sine of 45 degrees, that will be opposite, that will be 1, divided by the adjacent, so that would be 1. So the sine of 45 degrees is 1. Cosine of 45 degrees. Now to find the sine of 45 degrees, we need to find the opposite over the hypotenuse, and the opposite side would be 1. The hypotenuse would be the square root of 2, and we want to rationalize, and so our final answer here would be square root of 2 divided by 2. Cosine would be adjacent over hypotenuse, and that would be 1 divided by square root of 2 again. And when I rationalize, we get square root of 2 divided by 2. So sine and cosine are exactly the same for a 45-degree angle. Tangent of 45 degrees, that will be opposite over adjacent. Opposite side would be 1. The adjacent side would also be 1. So tangent for a 45-degree angle will be 1. Now when I go to work with my reciprocal function values, sine was 1 divided by the square root of 2, so cosecant of 45 degrees will be the square root of 2 divided by 1, or just the square root of 2. Secant of 45 degrees, the same thing, 1 divided by the square root of 2, so that would be square root of 2 divided by 1, which is just the square root of 2. So cosecant and secant of 45-degree angles are the same. Cotangent, of course, would be the reciprocal of tangent, so that would be 1. Notice that tangent and cotangent are exactly the same. The reason why they're the same is that we are working within the same right triangle, and you notice that if this is 45 degrees and this is 90 degrees, then this has to also be 45 degrees. So cofunctions of angles that add up to be 90 degrees or within the same triangle, cofunctions will be the same. So sine, we said, was the same as cosine. These are cofunctions of angles that add up to be 90 degrees. Cosecant is the same as secant, and cotangent is the same as tangent. So cofunctions of angles that add up to be 90 degrees will be the same.